First of all, I would say that to come here at Donsø is very exciting. It's a very special island with a lot of dedicated people, with a lot of knowledge about vessels and the shipping industry. First, I'm just going to tell you something about Høglund. We started out with automation. In the past years, we have also expanded our business into gas systems, LNG, fuel systems, and also into power with the batteries and the hybrid technology. When I'm talking about the challenge, it's about computers being installed in all different equipment on board a vessel. And we can see that it's going to be challenging to get all these computers to work together. How should they be connected together? And that is also a question about integration. Will the systems work together if they are delivered by different suppliers? And how to maintain each of the computer, because computers can live their own life. They can also need to be maintained. So basically, old system were controlled physically by manpower. There was no computers, of course. Then modern vessel is purely controlled by computers. Actually, vessels like this can be unattended. They can be controlled from shore, even autonomous. And there are computers in all different parts of the engines, rudders, whatever on board the vessel. They need to work together. Okay, so the microprocessor, it's very cheap, $10. For a small PLC, $100. And these have been the reason why it's so easy to install. When you look at the purchase price for a traditional relay control, you can see that it's pretty much costly, and the connection fee you have to connect, and then you have to change them later if you're going to do maintenance or change for this. It needs manpower. If you're going to duplicate them, you will have to stay the job several times. So this is traditional way. This is the modern control. Today you just put a PLC on board, and then you see that the cost of implementing this PLC is very low. But there are also challenges with this. Inside equipment today, you have computers in all equipment on board. Engine control systems, shutdown systems, governors, voltage regulators, you name it. Whatever there is a complex machinery, there is a microprocessor. And these microprocessors, they need to be programmed. And there is a software inside. This is the simple control of a lamp, very simple. On the left here, we have a connection with relays, traditional way, and here you have a connection with the PLC. So this PLC software the function can be done with a flip-flop or a set-reset gate, which you see on the top there. This logic is actually have the same functions. And we found this logic inside a system where it's actually doing the same performance as a flip-flop, but it's got a bug inside. I think the bug is if you keep the button pressed for more than 2 seconds, I think it will hang. But the point is that inside here you can't really see the software inside the PLC. That's the whole point. So how do you fault trace a PLC? If you have a PLC running equipment on board, how can you fault trace? Because this connection, any electrician can fix the problem, right? You can open the cabinet door and you can fix it. On a PLC, well, you cannot do any fault tracing on this circuit without having the software. You need to get inside this box. And when this PLC decides to stop the motor, in this case, you have actually no really trace of why it stopped. Because if you don't have any logging, you don't know what happened. So it's just stopped, and you have to try to figure out inside the software why it stopped. Sometimes you can't get to the software, and you will never know. And then we have parameters. On board and modern vessels today, you might have as much as 50,000 single parameters. One single of these parameters can actually kick off your vessel from operation. One parameter. And how can you keep track of 50,000 parameters? This unit here, it's actually a small unit controlling a valve for a PWM control, for a crane, for example. This unit has got parameters. So if you replace this unit with a new one, and you don't update the parameters, your $50 million crane might be not working correctly. But who knows about all these parameters? So this is a big challenge to keep track of parameters in different of the units on board a vessel. So the challenges here is about the understanding of software in the industry. This industry has traditionally been built up by engineers understanding the engines and the mechanical part of the vessel, and suddenly you get a lot of complicated software functions inside. So that's one of the challenges, that the industry does not have enough knowledge about the details in the computers. It's a new technology, the education and certificate rules, and of course, lack of computer understanding. And sometimes you're adapting technology you actually don't understand fully. Anyone of you have used a computer or a Windows computer or whatever, and when it does something you don't understand, you just reboot, right? But you're not able to understand what everything was happening inside the computer. That's one of the problems. So we also have a lot of copy. You copy a function, you copy a whole system without actually designing it for that vessel. And when you copy something, you get also all the faults and all the problems from the previous where you copied from. And the problem is to verify the software. How can you make sure that the software is working as it should? Let's compare. If you have a welder, the weld can be inspected, the weld can be x-rayed, and the welder needs a certificate, right? And then we look at an electrician. The electric cables can be verified, it can be inspected, connections are visible, and the electrician needs a certificate. And then we're going to look what is required by the software programmer, which is controlling everything on board a vessel. The programmer, first of all, the code is not visible. That means you cannot see what actually the programmer have done. You can just see what happens when you test it. So even though the result of the programmer is not visible, the programmer does not need a certificate. You can use any guy to program anything. Even he can do this job. So it doesn't matter who does the job as long as it works. This is today. You just test the computer. If it works, it's good. But the problem is that inside the computer, you have more combinations than you have atoms in the known universe. There is more combinations inside than there are atoms in a known universe. That means that even if you test a system for many days, you have never even tested 1% of the combinations. So you can't actually rely on a test of the computer system. You have to look inside, actually. You have to check the programmer, but you don't see it because it is inside. And most of the ship owners doesn't ask for the code. So that is a challenge. We can compare this software testing with, let's say, a dentist. He would like to install the electrical system in his house, right? And he goes starting to install, and he get everything installed. It looks very nice. And in the software case, right, you just test if the software works. So if you transfer this to the house of the dentist, there is this guy coming to check the electricity system. So he goes to the bathroom, switch on the switch, and the light works. He tests the power outlets. Yes, working. Check the heat on the sink or in the kitchen. It works. Actually, he approves the system because the light and the electrical system works. But he doesn't open the door. So if you open this door and look inside, this can be the same as the software guy, working. So if you don't look inside the software, you can actually compare this with an electrical approval without actually see the job, which I've done. So what is missing here? First of all, the skill requirements, certificate or whatever for doing software and hardware, like the electrician have to do, like the welder have to do, like all the others have to be certified. In the software industry or in the computer industry, there is no certificate. You can just go ahead. And then we have a test. As I said, there are so many combinations that it's impossible to test. So it has been developed a test called Heel Hardware in the Loop test. And that is a test where you attach a computer for testing the computer. So that works fine. But the problem is that how many combinations can you test? Even if you test 100,000 combinations, there are a lot of still actually more combinations than the atoms in the universe. So you can't test actually the software. You have to check the code inside. So that's why I say code review. You have to look inside the code and figure out how it's programmed. Like you see in the connection diagram for relays, you have to do the same in the software. When you're sending today, when you send a satellite out of space, the programmers of the systems, they work 3 and 3. One programmer, 2 readers, and they are change on reading the other code. That is the way they do. But for other business, we can take this. We can accept actually the problems or the bug. That's the reason, and it's going to be more expensive if you do like that. And then, if you have a proven track record, I mean, if your system performance, if your system is crashing every day, something is wrong. But today, it will be even just restarted. So people accept that systems are not working. This vessel had 2 main engines, where one of the engines suddenly didn't start. So they had to look inside the cabinet, and inside the cabinet there was a PLC. PLC cost about, let's say, $1,000. And this PLC was obsolete. So the vessel faced an off-hire of 14 days to 1 month just because an obsolete PLC were actually blocking the engine from starting. And there were no ways to start to get this system up running in a short time. This ferry had it all redundant propulsion. Everything was backup systems. There was one thing missing. The PLC for the gate in the bow didn't work. So the vessel were stuck with passengers, trains, trucks, whatever, for many hours, trying to figure out the PLC controlling the bow gate. This we had a mysterious shutdown on one engine. The ship owner couldn't figure out what happened until we were able to log the data, and it showed that the PLC controlling the engine was booting. It was rebooting once every 14 days. And when it was rebooting, the engine stopped and made a disconnection of the generator breaker. So that's some of the stories about breakdowns of PLCs or mysterious bugs. So what are the requirements? We would suggest to limit the number of PLCs on board. We would limit the types and brands of PLCs. If you have the same brand, same programmer, it would be easier for you to do the maintenance and to check the system. Of course, keep spare units so you can replace a unit. Require latest software to store on board, because a lot of PLCs vessels are running worldwide without the backup of the code on board, and that can be catastrophic. Keep necessary tools for upgrading the software. You will need a special tool to upgrade the software, and this should be on board the vessel. Of course, battery replacement, because if the battery goes out, you're losing your parameters. You can even use the software, and the system won't run. For example, the bow thruster can stop after a blackout if you lose the parameters, or if the battery is not updated. Revision and log handling and parameter log. Everybody should have a revision and handling of the software. They should have a parameter log, and to keep track on the different versions installed on the vessel. And of course, you should put quality requirements to the supplier, not accept anything you get from any supplier of this. And of course, you should update the hardware and make sure that it's not outdated, because if you wait 10, 20 years before you start to upgrade, you will have to upgrade your whole vessel. So, and of course, in the end, do never accept rebooting as a solution of the problem, because if you have the reboot, there is a critical fail on the system, you should fix it, just not reboot it. So this is basically my time. In the end, I would like to say something about the specification that we will need to, the ship owners should put this into the specification, make sure that when they build a vessel, they don't get these kind of problems with the PLCs. Thank you.
Thank you, Kåre. Thank you. I was thinking about, we were speaking before earlier this afternoon today about the digitalization and all the things, it's hardcore, but when it comes to the user, it's always human beings. And what do you think is needed from the shipping companies to cope with those digital systems?
Well, first of all, they need to be trained. They need to know what kind of equipment they buy, so they know how the equipment works. And of course, they need to have, as I said, a specification with details of what kind of equipment they will get in the vessels. Because today, the specifications is made up by a lot of requirements for the mechanical stuff, but for the computers, there is a very lack of specifications, and that makes the systems very often that they get systems that are too complicated or does not fill the needs for the vessel. And of course, today we are also doing with working with autonomous vessels, that the vessel would sail away without any people on board. So the guy would actually sit ashore to monitor, which have a...
But then you don't have to deal with the human beings.
No,
Then you have
not on board, but there are a lot of other problems
Yes,
popping up.
Yes.